Well, good morning, good afternoon, good evening, good night to everyone, wherever you may be across our lovely world. Thanks so much for joining us here again live for another episode of Serverless Office Hours, streaming on the AWS Twitch channel, on YouTube Serverless Land, and also via LinkedIn Live. So whichever channel you are joining us, you are absolutely most welcome. My name's Julian Wood. I'm a developer advocate here at AWS, and I'm joined with two awesome Java experts who we're going to be spending an hour with today. In no particular order, first up, Mark. Mark, we've worked together for a number of years, both based in the UK. So yeah, what is your journey to Java, journey to AWS? How can you land up being such an expert in what you do?
I'm not too sure about that, but yeah, I've been using Java since university. It really fits with my small brain. I like a very simple programming language, so it's just the language that I really like. And I've been programming as a business, like what I call business applications, so things that produce business functionality for a long time. And then I joined AWS, and I thought there was more that we could do with Java and serverless. So yeah, I've been kind of diving deep on that area for a while now.
Cool, excellent. And then from slightly further away, but still within Europe, Max. Max, also welcome to Office Hours. I know you've been on before, but yeah, how have you come to be doing what you're doing? And I know you're both are solutions architects, and you also work in the ISV division. So yeah, tell us a bit about that.
Yeah, definitely. So thanks for having me today, also together with Mark. So yeah, I've been a developer for almost more than half of my life. So I've always been a backend developer, and yeah, I have been doing a lot of Java. And I joined AWS roughly 3 years ago, and I've seen a perfect match for Java in modern applications and how we can optimize that for serverless. And that's has my journey basically the last 2 to 3 years, also together with Mark. And yeah, hopefully we can share a lot of best practices on that with you today.
Cool, excellent. Yeah, and I know we're going to get into lots of things that as well. And I actually love the sort of journey story of people who, have done things in a sort of big traditional way beforehand, and then they come to AWS and they realize how sort of big and crazy it is. And then they also see serverless and they think, oh, wow, actually, these old ways of doing things can be very applicable to serverless. So that's what I love, the sort of approach. It's not the other way around where people come in and they go, oh, no, that's not going to work. So I love all the passion you've put into it. Just before we get on to Mark and Max's talk all about Java, let's just look back over some things that have been happening in the past week in the world of serverless. Last week's stream was Apache Airflow and step functions. So if you're all interested in workflows, Fernando Gamero did a really nice chat talking all about how to compare differences between the two. And that is on our Serverless Land YouTube channel, along with all other Serverless Office Hours episodes. In terms of what's new, some things just picking off the sort of top few. If you're into AppSync and you're doing all your GraphQL kind of things, new metrics is always appreciated. So that's some things coming out of AppSync. Yeah, an interesting one. Kinesis actually part of Kinesis did a bit of a rebranding exercise. So Amazon Kinesis Data Firehose is now just Data Firehose. So I don't know the backstory with that or who didn't want to be called part of Kinesis anymore. But Kinesis I know is a whole suite of different products. Amazon Data Firehose is what it is anymore. AppSync as well, more things, environment variables in the GraphQL resolvers and functions, and also SQS. So that can be interesting. I know some interesting use cases that people have been talking to me about. Payloads up to 2 gigs. I think SQS standard is 256K. And so now there's an extended client library for Python for payloads up to 2 gigs. So that could be useful for you. Some recent blog posts as well. The top one we are going to be covering today, but Dennis has done a really good blog post on replatforming Java applications using the AWS Serverless Java container, and we're going to cover some of that today. Josh Khan has got a really good blog post about connecting EventBridge and AppSync, and a really good use case for using AppSync to update your front-end applications, for example, and then just sending those messages or updates from EventBridge to AppSync, and your front-end apps get updated. It's sort of, magic WebSockets-ish behind the scenes, and yeah, really cool use case if that is of interest for you. And that, along with all other serverless blogs, S12D is our link shortener link, and that /serverless-blogs, and that heads over to the AWS Compute blog with all of our serverless blog posts. Some learning guides which are available on Serverless Land, and I'm hitting myself because I didn't put a link on the page. But yeah, if you're into Terraform, which lots of people are, I was actually looking and seeing some internal stats, and it's incredible how popular Terraform is for building serverless applications on AWS. So Anton and Debasis, well-known contributors have put this learning guide together. So it's serverlessland.com/learn, and you'll be able to navigate from there. And that's all building serverless applications with Terraform. And another learning guide that has been coming out is Uma Ramadas, who's awesome, and she's put this together all about integrating step functions with containerized. I'm missing an S. What's going on today, Julian? With containerized workloads. And so, yeah, super useful to be able to use step functions as your orchestrator, and then not necessarily use Lambda or API gateway, but also now some containerized workloads. But today we're talking about Java and about refactoring Java applications to serverless. So Max, over to you. What are we talking about today?
Yeah, thank you, Julian. So Mark and I have been working, and a lot of other SAs have been working over the last couple of years with customers on modernizing their Java workloads. So today we want to take you with us on a journey on how that can look like in practice. So we basically want to show you an example architecture, and we pick 3 parts that we regularly see in the industry. And then we show you how you can move that from a more traditional way more to a serverless way of doing things. So we will do some kind of whiteboarding in between and show you what are the parts that you need to or want to watch out for. And yeah, we thought it's best to show that on a concrete architecture. So I'm not sure if you've covered that in the serverless office hours before, but we want to structure the application or the refactoring around serverless video. So serverless video is an application, right, that your team has built, so our developer advocacy team has built. And basically, serverless video allows broadcasters to stream videos directly to thousands of users. Maybe we can also put the link in
There we go.
The chat. Exactly. So user can start a stream and people can then watch it. And yeah, so I can share a bit about like what is underneath like serverless video, right? So it's fully based on serverless technologies like API gateway, Lambda, Fargate, DynamoDB, and it's all built around independent services that are decoupled in an event-driven nature, and some parts are also orchestrated via AWS step function. It also has a plugin architecture, so you can technically hook into that process also a custom plugin. So there are things like automatic generated AI titles generated with Amazon Bedrock, for example, but you can also create your own plugins. And we thought that for today, we want to focus a bit on a specific part of that whole video streaming landscape. And we want to extend serverless video in our example today with a clap functionality. So we want to basically allow users to, first of all, search for videos to see what is currently on, and then sending claps to it. Like, oh, I really like it, for example, and then you can hit the clap button all the time. And then after that has been done, after a certain amount of time, so for example, after an hour, we want to send the video creator a notification saying on how many claps the video has received. And
so is this the emojis that are on the video? Is this or is that a separate functionality?
Yeah, so this is not the one that you currently see in serverless video, but it's more like to set the stage for the refactorings. We wanted to choose that because if we look at the next slide, we will see that we will focus on 3 specific parts of the architecture that we very regularly see in customers' environments. So first of all, to be able to search for the videos, we need some kind of API. So we need a REST API to read the videos. And then when we think about how we watch videos, we probably don't hit claps just once, right? You're constantly pressing it. So we expect a lot of writes from our users. So therefore, we want to handle them asynchronously. And we will talk about that a bit later on how we are going to implement that. And the third part we want to focus on is a scheduling part. So we want to have a time component in it that after a certain amount of time, we want to trigger essentially an action and then say, okay, this is the amount of claps that has been received. And we are going now to show you 1, 2, and 3 and more detail on the whiteboard, and dive deeper on how you would have done that with Java in a more traditional architecture. So that is how you would probably do it in a more traditional architecture. And we will look at those 3 components then specifically and show you how you can refactor them. And I think with that, we could already jump into the first kind of example, which is the read API for listing and searching for the videos.
Excellent. So yeah, I'm just putting up we actually did a session on serverless office hours, on serverless video on serverless office hours a few weeks ago with the whole team. So yeah, serverless video is just a fun streaming application we've built. Lots of cool, Gen AI and Java and Lambda step functions of InBridge all behind the scenes to put together this really fun experience. So yeah, if you want to see it live and see how it works, yeah, that would be super cool. Yeah, and just remember we are live, so send us your questions, send us your comments. Love to know what you're building with Java. Love to know where you are and what you're doing with serverless. So yeah, Mark, should I switch over to your whiteboard?
Yes. Sorry, just swapping things around.
That's quite all right. That's why you can see we are live. We are here sticking the things on the screen as we go. So I think as part of the story with the refactoring is not just sort of doing a lift and shift of a Java application onto AWS, let alone, or onto serverless or that kind of thing. There's a sort of looking at the application and deciding, how to maybe split it up or pull some sort of things apart from, what previously would have been a big monolithic code base. Is that the sort of general idea?
Yeah, absolutely. So we're just taking a look at the first part of this application, which is the read API. And obviously, when we're talking about architectures, it's hard to discuss without talking in depth about lots of different and non-functional requirements. But obviously, This is a simplified architecture for a reasonably big application, but not something the size of Facebook. So we're talking about users coming in, accessing videos via some sort of load balancer, which should then be handled by a series of EC2 servers. And these would run our Spring Boot application. So our Spring Boot application would have Spring Boot Web as one of its dependencies, and we would probably implement this using at-rest controller. So if you've ever done any Spring programming or any Java programming, this is very familiar style of programming for Java developers. And these would then access some sort of data store, whether this was RDS, MySQL or Postgres or some other database like Oracle or even a NoSQL database. And then obviously we would return back. Now, this is a perfectly good architecture and will scale very well, but obviously there's some downsides to this as well. So obviously with our EC2 instances, as opposed to a serverless architecture, we're going to have to manage the scaling of these components. We're also going to have to manage the security, so patching of the operating system and of the Java runtime. And application load balancer is just a different offering to something like API gateway. So when we look to refactor this, I think it's quite an easy first thing to think about is actually quite a drop-in replacement is to bring API gateway into the mix here. So I can quite easily swap that out, and I can bring in API gateway as pretty much a drop-in replacement. It will do exactly the same job, but I'm actually going to get a whole heap of extra benefits. So I'm not really going to touch on many of them right now, but things like throttling, or if we wanted to have different usage plans in the future, if serverless video went B2B in the future or something like that, there's a lot more API features around API gateway compared to application load balancer. And we'd still be able to load balance across targets. But we can also look at using Lambda instead of EC2. Now this is a little bit more complex because when we shifted from application load balancer to API gateway, the format of the requests are going to change slightly. So instead of receiving HTTP requests, we're actually going to receive a JSON object. And that JSON object is going to look very similar to a HTTP request. It's going to have all of the same data, but it's just being formatted in a JSON structure. So it's now kind of down to us as developers and solutions architects to consider how we migrate the application logic to meet that change in input format. Now, the way I would do it to start with is to use a open source project called the Serverless Java container. And this is an open source project that you can add to your Spring Boot or Jersey and some other projects that we also support. And it will do the adaptation between HTTP and JSON format. So you can keep your Spring Boot application pretty much as is. You don't really have to change anything. You add this as a dependency and change the entry point of your Lambda function to be a handler which is included in this project. And then from your point of view, your Spring Boot application is booted up and the REST controllers are hit every time a request comes in. So it's a really neat way of limiting the amount of refactoring that you're doing at any one time, because obviously it's quite easy for things to snowball and you end up changing everything. But this is a really neat way of trying out Lambda for the first time. If you're an established Java engineering company, this is a way of taking these existing Spring Boot applications that you have and running them on Lambda. And this will mean that you get to have all of the operational benefits of Lambda. So all the scaling, security, pay-per-use, and it's a really slick operating model.
So the serverless Java container has also, I know, recently been updated to version 2, and I did in the chat and on the screen I did do the GitHub repo for the code, and then also the blog post which is explaining everything about it. So I mean, just quickly, what does version 2 bring? Because I think you'd mentioned before we were going in there, this has been around for 6 years, so this is not a new thing. What's cool that's new?
Yeah, it's very well established. It's used by many people at very high scale. Version 2 has been to adopt the changes made to Jakarta APIs. So a lot of you, if you've been moving to Java 17 and Spring Boot 3, have noticed a namespace change in some of the web APIs. So this version of the serverless Java container allows you to run Java 17 and Spring Boot 3 applications. So if you're moving that direction, you'll need to jump a major version as well.
Yeah,
and I think, sorry, carry on, Max.
We also added support for GraalVM native images. So if you want to work with that, we added support with that in collaboration with the Spring team. So you could now you basically can use the serverless Java container to port your application on Lambda, and you could even create a GraalVM native image out of that, and it would be fully compatible. So those, I think, the two major points we've added. So Spring Boot 3 compatibility as well as GraalVM native image support.
Okay, and I mean, I understand that the sort of modifying an existing Spring Boot application isn't that complicated, because you just add the dependency to your file with Maven or Gradle, and then I think that's literally just a wrapper that's going to go around your code and is going to handle all the HTTP requests. And then I think the other thing you need to do is maybe change your handler, I think, just to point to the actual Lambda container handler, and that I think handles most kind of things, which is pretty impressive.
That's it. And one additional benefit, so traditionally, if you have it Spring running in a container or in a VM, you would always have in Spring Boot, for example, you have per default Tomcat HTTP server, for example. You can now even exclude the Tomcat because you don't really need it, and the serverless Java container will do the translation for you. So you also basically can exclude a couple of dependencies when leveraging that.
does that speed things up, or is it a bit of a like for like swap out?
It speeds things up in a sense in comparison to other like HTTP adapters, for example, right? Because you don't need that additional HTTP server running anymore, right?
Okay, yeah.
So it definitely speeds things up.
Yeah, which is a good segue to the next point. Because this is a synchronous API, we want to have the best performance at all times. So every request is going to be a request by a customer, by an end user. So we want to take every advantage we can do to make it as fast as possible. So the thing that we're really looking at here is a function called Lambda Snap Start. And this was introduced not last year at reInvent, but the year before, so reInvent 2022. And Lambda Snap Start is a performance improvement feature for Java on Lambda. And the way that it improves performance is that when you upload a new version of your code, you can make a new function version. And when a function version is created, we're going to take your code and initialize it on a separate worker. Once that initialization is finished, we're going to take a snapshot of the entire virtual machine that function was running on. We're going to encrypt it, either with your key or with our key, and we're going to store it in our service team storage. And then whenever you need a new execution environment for whatever reason, whether you're receiving more traffic, we're going to create new execution environments, not in the normal way, but we're going to take that snapshot, we're going to load it, and then we're just going to resume that snapshot from where we left off. And this is actually a lot faster than creating execution environments normally. So this is up to 10 times faster for running workloads like Spring Boot on Lambda, which is fantastic. And we see many customers who are having restore times of around a second, which is fantastic.
Yes, I mean that's incredible for Java, because one of the I still answering questions even internally with people about freaking out about cold starts for Lambda, and cold starts certainly can be an issue. The busier your application is, the fewer cold starts you actually have. But let's not be flippant and say you don't have cold starts. And I mean, the headline thing is for Java, Snapstart basically pretty much eliminates your cold starts. So under 1 second cold starts, a whole world gets opened up of doing synchronous APIs and a whole bunch of things which maybe you just couldn't do beforehand. And there's no code changes, there's no dependencies, there's nothing to do. You just sort of turn it on, make sure you have a version and alias. Make sure you have a version and alias. I'm sure Mark and Max have been saying that a million times. But it's just such an easy way. And it's some pretty impressive technology behind the scenes that sort of Lambda's done on your behalf in conjunction with the Java community. There's some cool Lambda tech, but also some cool Java hooks and everything that are not Lambda specific. So this is really cool stuff that is just part of your Java, the way Java works.
And you forgot the best feature, Julian, which is it's free. So it's
of course.
It's also not a feature that you have to pay an additional amount for. So, something like provision concurrency, you're paying for that. Those environments, whether they're used or not, obviously you're paying less for them when they are used. But if they're not used all the time, then you are paying basically a premium for them. For Lambda Snapstart, you're not paying for anything. You're not paying for the storage of any of the snapshots or anything like that. So it's a really nice feature. I would imagine that pretty much everybody who's using Java on Lambda should be looking at Snapstart and saying, why shouldn't we turn this on for all of our functions?
I mean, is that the messaging that Mark and Max you would say? It's released just over a year ago. Some people, may be worried about this as experimental or weird or odd. I mean, it's just something that, if you're running Java applications and you are, you want to improve your cold starts, because I know we're going to talk about asynchronous kind of things, and, maybe cold starts don't matter as much. But for synchronous kind of things, is it just the kind of thing like there would be no reason not to use Snapstart, or is there some nuance in that answer?
Yeah, I'll talk about some of the nuances, but I'll also say that it's also very much the direction of travel in the Java world. So in the Java world, we talk about a new project called Project Crack, which is coordinated restore at checkpoint. And this is part of a project which is currently going through the OpenJDK process. So it isn't an official project or officially part of the OpenJDK at the moment, but hopefully in the future it will be. And this is a project that allows you a series of APIs which help you to understand when an application is being checkpointed. So this was support for this was recently added in Spring 3.2. So Spring are very much interested in this checkpointing or snapshotting technology, and I think it'll be something that we see more and more, and not just in serverless and in Lambda, but I think you'll see more about checkpointing and Project Crack and its use in containers in the future.
Yeah, that's maybe something also in the Java space, or especially Java developers need to understand. So when we talk about Snapstart, it's actually a technology that is based on the Firecracker micro VM. So the snapshots are taking off the full micro VM. It's not specifically leveraging like just the JVM snapshotting like Project Crack does, for example. So this is a difference. What we rely on from Project Crack is that they define interfaces on where you can define those hooks. So obviously with Snapshot, it sounds right, it's super convenient, and we talked about a lot about the advantages, right? But there are some things that you need to think about. So for example, if you have a secret in your snapshot, you need to think about when you restore the snapshot, is that secret still valid, for example? And there are hooks that you can provide in the code that you say before snapshot and after restore, where you can check for things that should be maybe reinitialized, like network connections also to a database or something. And the frameworks like Spring are doing a pretty great job, also Quarkus and Micronaut, on leveraging those APIs and doing those things that they need to do from a framework side within those hooks already. So and since we are also relying on those Crack interface API, we can leverage that also with Snapshot. So here we have some correlation between the projects, but the snapshotting is different. It's not on the JVM level in Snapshot, it's on the whole micro VM.
Yeah, but I still love the story that, the actual Java part of that story is specific, is part of Java, not specific to Lambda. So if people are using this technology and they want to, in the future improve cold starts on containers or even EC2 or this kind of thing, that technology is part of Java. It's not, using Lambda, I'm going to be doing something a bit weird with Lambda that's not going to be portable. So yeah, I love that part of the story.
Yeah, absolutely. So the fantastic thing is, as I've been exploring this project more and more, is that when you start doing this yourself and trying to do it on other platforms, you actually realize how much Lambda is doing for you. How actually storing snapshots in an encrypted way and then retrieving them in a low latency way is actually quite a heavy lift. So having it all done for you by Lambda for free is actually pretty amazing, and you appreciate it more when you see how you would normally have to do it without a managed service like Lambda.
Yeah, and we have seen also customers experimenting with that or finding new patterns of doing things. So imagine you always, before you're doing some kind of calculation, you need to download a data set from S3, for example, and then put it in memory. You could now do that, load that into the snapshot. So that means when you restore it, you already have the data there in memory. So you don't need to make an additional S3 call and wait for it. So we see people really optimizing their whole applications now around that snapshotting, which is pretty great to see.
Yeah, absolutely. So I think with the time as it is, I think maybe we should move on to the next step.
Yeah, right. Yeah, I think here we basically covered the most important parts. So the API gateway, the serverless Java container, and Snapstart. Those are the three, I think, key takeaways for REST API. Obviously, you can integrate still with your RDS database or move to Dynamo if you want to have it more in a serverless way. But I think essentially you can see it doesn't really take a lot of steps. Add serverless Java container, add this entry specific handler, and you can run your Spring Boot application on Lambda.
Yeah, I think because this is quite a discrete microservice, it's more feasible to change database technologies like that. And I think in this case, it does fit NoSQL quite well.
And just quickly, not to derail too much, but do you see a lot of customers using RDS proxy between Lambda, when using Java and then using and connecting to RDS databases just to help with connection pooling, or not so much?
It just depends on the use case. So sometimes, depending on the traffic profile, RDS proxy is a really good solution, and sometimes it's an extra step. So it's a place to dive deep into, and work with solutions architects to pick the best architecture.
All right. Yeah, I think then we can go to the second part. So we said we can now search for videos and we can retrieve them. And now we want to send those clap reactions essentially. And we said people are probably using that button quite a lot, and we don't want to overload our databases exactly. So we want to have a quite scalable architecture. So we don't want to directly put it synchronous in a database, but we want to do it asynchronous. So in a traditional architecture, you would probably try to do that, decouple that via a message broker. So imagine you're sending a clap, and then you would have maybe a receiving API that just puts that onto a message broker. So traditionally it could be something like RabbitMQ or ActiveMQ and something like that. And then you have workers reading all of those claps, maybe do some kind of batching, right? To not for every clap write it to the database again, but read maybe batches of 10 or batches of 100 from the specific message queue, and then write it to the database and increase a counter, for example. So for specific video, we would then just increase the counter by 100. So this would be the traditional architecture and how you would design it in a more like server full way, right? So you have the load balancer that distributes it to the API servers that are receiving it. They then, in like a store and forward way, put it on a message broker. And then you have the queue workers that also need to scale, and the databases. And what we have also in the first example seen, right, when we talk about that server-based architectures, we also need to keep in mind that we have multiple instances of all of those things running, because we want to have them highly available. So we have 2 or even 3 of the application group or API servers running. The message brokers are usually also in a highly available fashion. So you have 3 nodes. In Kafka also you have at least a setup of 3. And then you have multiple workers reading from that. And then even on the database level, you have something like active standby, that if the database fails override, that you have like a secondary that you can write to. And if we look at that from a serverless perspective, so if we would redesign that to a more serverless approach, we would, again, as we've discussed in the initial way, we would leverage API gateway to receive the request, right, to provide this HTTP REST functionality. And then we can leverage something which is very powerful, which is API gateway direct integrations, right? So instead of having an intermediately publishing something to a message broker, we could directly publish from the API gateway our claps, for example. Just think about it as a JSON payload containing the video ID and your user ID, for example, that is going to clap, right? So we can directly put that on the queue. So we are actually saving one piece of compute in between, because we're just proxying the HTTP to directly an SQS queue in that sense, which is also fully serverless. So no need for having multiple brokers in a networking setup or something. We already can send it through to the SQS queue. So this is a quite powerful concept that we can leverage here. So for the end users, we would just get back 202, I think, accepted, for example, right, with a reference ID, but we don't really need to have any additional compute layer now in between. And on the SQS side, from the workers, we can SQS directly integrates with Lambda. So we can also use Lambda here to get the items from the SQS queue. And this is also, I would say, a rather powerful concept, because if you think about in a container environment or in a VM-based environment on how you pull from a queue, that requires you to set up like a polling library or like a client, for example, that reads from the queue. So you have some kind of logic that is polling from the queue. And here you have a direct integration between SQS and Lambda. So you don't need to write any polling code. You, in the handler method, so in the entry, you will already get your messages as an input parameter. So you have a list of SQS messages, for example, or it's called SQS event to be precise. Yes. An SQS event has, I think, a method called get messages or something. And then you get already the list or the batch of the messages from that queue automatically. And this is very powerful, right? Also from a scaling perspective. So Lambda scales automatically with SQS. So when it sees I cannot catch up with the number of items that is added to the SQS queue, it will automatically scale out and create more and more instances of Lambda. And if you think about doing that in a more traditional environment, you need to set up scaling policies on metrics and things like that. So it's a bit more cumbersome, and you get that here really out of the box. So I think especially for queuing and this kind of processing, this is really a powerful concept of integration.
Yeah, and when Max was talking about Lambda polling, there are actually two parts of it. One is your, in this case, Java code that's actually going to do the processing of those SQS messages. But behind the scenes, Lambda is going to poll that SQS queue for you and create those batches, and you can also do filtering and all that kind of thing. But that is free. You're not paying anything for that. That's got nothing to do with how long your Lambda function is going to run. So yeah, you get a whole bunch of functionality just out the box. And yeah, the scaling is pretty high. It's really high. In fact, we improved the SQS Lambda scaling recently. I think it used to, it's jumped up, I think 6 or 9 times or 12 times. One of those numbers. I'm fudging the numbers, but yeah, basically if you're polling from SQS, it's going to scale up really, really quickly. So any of your scaling concerns are hopefully and that just happened automatically with Lambda. I'm sure somebody phoned up the AWS support line and said, something's wrong. My SQS queue is being drained too quickly. What have I done wrong? And no, we just improved it for you. Enjoy it.
Exactly. And here we can therefore remove like the rapid listener, for example, that you are used to via your framework, when we directly deal with that SQS event. And as you already mentioned, we get like cool things out of the box, right? So we have, for example, we can return partial batch failure. So if we're able out of a batch of 100 to only process 90, we can report back only the 90 that I was able to process, or only like the 10 items that I couldn't process, right? And would therefore not block the queue, right? So I have already built in functionality that would otherwise be quite hard to implement, things like dead letter queues. So after, if I can process an item for 3 times, you can put that on a dead letter queue. You have the batching, as you mentioned. So you have a lot of things out of the box that are otherwise quite cumbersome. So how would we here design it here? So we have a repository that we can share at the end on how we implemented it. So basically what we're doing is we're reading batches of, for example, 100 or 50, and then we see in those claps we essentially group by the video ID. And let's say out of those 100 I read, maybe 80 were for video 1 and 20 for video 2, right? We group them based on the video and then only do 2 writes to the database, for example. And you can do that in one actual request. I think it's called batch item write. We would need to double check that, but there's a functionality for Dynamo to send that in one request to the database. So I would have one entry saying, please update video 1 and increase the counter by 80, and for video 2, increase the counter by 20. And here's, so therefore we can, like a very high amount of claps, we are able to write very efficiently to Dynamo here in a fully serverless way. So if there's no requests coming, right, we would also not need to pay for anything in that current setup. Yeah, I think it's called batch update. I would need to check the exact API name, but we have it in the repository. And yeah, and I think if you compare that to the traditional architecture that we have seen for asynchronous writes, right, I think we've simplified here this architecture a lot. And from a Java perspective, what you would need to do, we have the AWS Lambda Java events library that is open source. So you get like a POJO on how the SQS event looks like. So you would not even need to have a framework for this. You can just write plain Java with that POJO and deal with your SQS messages and write them with our SDKs v2 to DynamoDB. So pretty straightforward implementation of handling asynchronous tasks.
Yeah, pretty much you would look at where your code had that rabbit listener annotation. That would probably be deserializing a message, taking your business object from that, and then calling some sort of business operation on it. So it'd be very similar. You would have an SQS event. You would look at how many messages were in that event, and then you'd probably just call the same business logic just with your business object that's been input into the message. So be a very simple code change.
Yeah. All right, Mark. Should we look at the last one, at the scheduling part?
Yeah, absolutely. Oops, showed the end state there. So this is something that I used to use a lot when I was a customer, and this is scheduling things to happen in the future. And it's actually an awkwardly difficult thing to do if you're in your own data center, or if you're using some of the lower level services like EC2. So if I want to say something has happened, and in an hour's time I'd like something else to happen, it was always a really awkward task. You'd have to have some application which had long-running threads, constantly remembering or thinking when to act. So, if you've been working in the Java space, this is probably implemented using an open source project called Quartz or Job Runner. So you need long-running Java applications in a HA configuration. You also need a relational database, again, or the data store, some sort of data store in a HA configuration that's actually going to store the state of these schedules. So you're going to need both of those components, and they're always going to need to be long-lived. And this was always a really awkward thing, because you had a certain amount of fixed costs for using the first use case, which meant that your first use case of scheduling had to be pretty enormous, because you'd have to set up all this infrastructure, even if all you wanted to do was to schedule one activity later in another date. So it was always a bit of an awkward thing. You always had to kind of bolt it onto some other services or share a database and try and hope that no one minded you using their systems. So you would use Quartz or Job Runner to say, schedule this to run at a certain time, and then Quartz would know how to then call your Java code, and then that would start invoking, and then that would invoke your business logic, and then that would send a message to a user, whether it's Slack or email or some other sort of system. So this, I think, has improved just dramatically in the last few years, and using serverless. The main difference now is that we have something called Event Bridge Scheduler, and this is a fantastic feature of Event Bridge, which allows you to have a huge amount of scheduled activities whenever in the future you like, and it's very different to our old mechanism in Event Bridge, where you used to, or you still can, have a cron trigger. This allows you a much richer set of functionality, so not just at a specific date, but a time relative to now. So this allows you to have millions of different schedules available. It's pay per use. You don't have to pay a set amount to have a single trigger. So it's a lot easier to use, and a much more serverless model. So I can actually take away, I don't need this database. Obviously, I'm removing this for brevity. We still have our RDS database for other parts of the system, but not for the scheduling part. So now our application can write to the scheduler, the Event Bridge scheduler, to say, I've received a new serverless video, and we think it's going to be really interesting, and we'd like to tell the creator how popular it has been. So put an item in the scheduler and tell me when something has happened in the future. So this is exactly what will happen. In 2 hours' time, the scheduler will invoke a target, and that target can be one of a large group of things. But in this case, it makes sense for us to have a Lambda function because this is a very discrete piece of work. It's well bounded and it's event driven. It just fits the serverless model really well. So in a period of time, a Lambda function is going to wake up and we're going to move the business logic of actually sending the message to users. We're going to take it out of this application and we're going to put it into a Lambda function. And this means that we're actually lowering the amount of code that's receiving events and putting them into the scheduler, and we're separating that and simplifying our code base even further, which is really nice. Now, this application, again, just like in the other cases, this is just receiving a message that something has happened, an event that something has happened. And again, it's a perfect fit for a Lambda function, whether this was being received by EventBridge or SQS or some other messaging system. Lambda is really well placed to receive those messages in a scalable way. So our architecture just kind of falls to pieces and simplifies really nicely in that we receive a message that something has happened. We write a schedule into EventBridge scheduler. That scheduler wakes up in the future, calls our Lambda function to do some business logic, and then we send out how many claps that customers have received. So we'll need to go fetch those claps from our DynamoDB data store. But apart from that, it's actually a really simple architecture.
Yeah, so you do not need to have those initial threads running again in the background, right? Just checking, am I ready to do something? Am I ready to do something, right? I can really offload that completely. So in serverless video queue, I get maybe all the new videos. I have the Lambda, I say, please, in an hour from now, create a notification, and that invokes then this other Lambda function. No need to do any kind of long running tasks, not need to worry about the persistence of the jobs or see if jobs already have been executed. And this is something, right, that has been quite some work in the traditional scheduling systems when you develop them. How do you persist the jobs, right? How do you check them? How do you mark a job as completed? So all those things are abstracted away via an API for you, and you have that separation also from creating a schedule and then also scaling the actual logic that executes your schedule later on. So also the scaling here again on, let's say you have thousands of notifications in an hour from now, right? You also don't need to worry about that scaling anymore, while before that you might need to scale the whole application to be able to send that amount of notifications. So it's also a very powerful concept.
Yeah, previously, if you had a large number of things to be scheduled in the future, you'd also have to have a pool of workers, worker threads ready to receive those schedules. And if those worker threads weren't ready, then it would start backlogging. So this schedule system invoking a Lambda function and both having serverless pay-as-you-go model and serverless scaling it's a really nice fit.
Just one of the questions with all of these sort of refactorings is, obviously we're reducing the amount of Lambda code. For some people also see this as going, oh, but I'm used to writing everything in Lambda code. That I understand. I have full control of it. Now when I'm introducing some of these other services, now I'm having to learn about SQS, or I'm having to learn about EventBridge Scheduler. How do you approach that with people? How should people think about the sort of trade-off between all the code I'm running, which is obviously their own liability, yet leaning into these managed services and having less code to worry about?
I think it's something as an enterprise developer in using things like Java. I think we're kind of used to for a long time. There's been a very rich history of event-driven programming in Java, and also programming with interfaces and refactoring in mind. So Java gets a bad reputation for being verbose, but also it really allows us to change architecture quite easily. So things like Spring Boot and other frameworks allow you to support in a in a really fantastic way, receiving messages from many different sources and being able to refactor between the two really quickly. So things like hexagonal architecture it's all very familiar.
Yeah, and I think also the amount of, or the code that you specifically addressed right so far is actually this polling logic and the scheduling logic, right? This is usually boilerplate code. So this is not something that is worth anything to your business. And I have not had many conversations where people said, oh, I really enjoy writing a lot of boilerplate code just to get that messages from the broker, right? So actually we're reducing the amount of effort, right? And I understand that at the first time, right, you need to get familiar of how you handle the AWS SDK and how you authenticate and what is IAM, right? And what about the permissions. But in the end, it's not giving you more work to think about, it's giving you less things to think about, and you only write the code that actually matters to your business. So I would just look at it from that perspective.
Interesting. Yeah, I actually like the initial comments of, I suppose I'm extrapolating that, because Java's been around for decades, new frameworks have come and gone. Java developers are, well seasoned and grizzled and know how it all works. But because it's been around for so long, people who are writing in Java are used to refactoring things and are used to using new frameworks and new versions of Java and interfacing with previous things. And they may have used ESBs in the past, and then they were hard to use, and then they've used now SQS or MQ, and things have naturally evolved through the time. And I suppose Java being as rich as it is, as you say, it has all these interfaces, and so yeah, swapping out an interface that's going to poll from Kafka or MQ and to poll from SQS isn't mentally such a big shift.
Yeah, and we have to say the frameworks are also like Spring, Micronaut, Quarkus. They're really doing a really great job in abstracting also a lot of those things. Also, they make local testing super easy also for Lambda functions. So definitely look also into those frameworks that you are familiar with already. They have great support, all of them for Lambda functions as well.
And then just to continue that sort of train of thought, that some people think that, okay, they refactored all of this, but they have a bit of a worry of using Lambda of, okay, well, now I'm going to be locked in, and then how am I going to evolve? And I can't then move this elsewhere. Yeah, what do you say to people who have that worry?
Yeah, I think again, so if you also have the frameworks, there's really, you can easily take, for example, a Quarkus application, run it locally, run it in a container, and deploy it to Lambda with the very same code base. So the frameworks really provide those abstractions. There are even abstractions that basically you do not have to use the Lambda specific handlers, but they provide the functional interface that is very common in Java. So the frameworks really give you that flexibility. So that shouldn't be really a big decision factor, I would say, in that discussion. I'm not sure, Mark, how you see that.
Yeah, I think if we go back to the Reed case, this was specifically tailored towards not making that change. We've taken a Spring Boot application basically as is. We're not deconstructing it any further. So if this didn't work out for whatever reason, you just put it back onto a container or put it back onto EC2, and you haven't actually you haven't spent a lot of time breaking that REST controller out into small pieces or anything like that. You can run it as is and not invest any further time. If in the future this is an approach that you really want to take, then you can invest more time in it. But this is a really good way of getting started on a stepping stone towards a serverless architecture.
And I think it's coding best practices in general to have bounded bits for your bit of code and a function that you're going to call to respond to something that is your business logic. That yes, you're going to take something from an application load balancer, and tomorrow it's just going to be a formatting for an API gateway. But ultimately, it's going to send it to your business logic, and that's going to be the same. In fact, that's got no knowledge of how the request has come in, and that's just general good coding practices.
Yeah, exactly.
Yeah, often we're just changing the adapters, which is the front of our applications. We're not changing the business logic. So, always keep that. I always try and keep that in mind when I'm writing code myself. I have that in mind.
And one thing to tease out slightly, I think some people also think that in order to do serverless well, you have to get to the end state. Otherwise, you're doing a sort of bad kind of thing. And I know a term I've used and abused incorrectly has sort of been about the lambda lith, where we talk about a monolith squeezed into a lambda. And I've very much changed my mind on that. Not from any malicious attempt before, but people out there thinking, hang on, I've done a really good job. I've had a proper Java monolith, which has been an EC2 instance with a gig of RAM and 10 gigs of RAM and thousands of functions in that, and I've decomposed that, all that doing well, all done that really well. And you're telling me I'm doing still a lith in Lambda, I'm doing something wrong. And I think, the message I know I want to try and evolve is to say, you can do this all in little bits and pieces, and actually having, even initially starting in this use case with one big Lambda function with all your roots in that, if that works for you and it's operationally simple, great, and then as you bump up against some scalability of security or organizational concerns, then you can future evolve. And because you're already using a serverless model, things are you're going to be able to make those changes much quicker.
Yeah, absolutely. So an example of that is we could have one Spring Boot application that had, our reads and our writes. This could be the same application. But because we know that there is a different architectural behavior for the writes, it makes sense to split that out. But that could easily start as the same Spring Boot application, which is deployed to EC2. But when we refactor that, we can start to look at the different behaviors of the API and start to break out the bits that make most sense.
Cool, excellent. Yes, I don't think you're always doing it wrong. Yeah, Max, you were going to say something.
Yeah, we just wanted to share all that we discussed today. We have as code ready, so all the serverless solutions we have as in a GitHub repository where you can look at the implementations of doing the asynchronous task, event-rich scheduler, and how that feels like. Not sure, Mark, if you also have the other resources we wanted to share.
Yes,
on the screen, or we just put the links here. I think
I'll put that in the links. So this is the sort of refactoring to serverless learning guide. There's a whole bunch of links on that as well. There's actually one which Mark and other people have done before, which is this is sort of more a lift and shift. So if you're re-platforming onto AWS and you want to start, that's it. There's a general landing page which has actually just come out recently, which is all about Java on Lambda on serverlessland.com. So this will this has got links to workshops and guides and video kind of things. I'm just pasting. There's a Java on AWS Lambda workshop. Let me put that as well. We then also have an immersion day, which I will do the link as well. Yeah, so a whole bunch of different kind of things you can do. Lots of content that we've been putting together, and Max and Mark have been fully involved in all of that. I didn't get to so many questions. We didn't have so many, but just thank you, Alexi, for joining us. You weren't that too late. Hopefully you got it was useful. Joel, happy that you joined us as well, and Gary as well. In about 2 seconds, Falling Task, thanks for joining us via Twitch. Can you use this for monolithic web applications like with sessions, etc.? Should we take that? We've probably got 10 seconds before we can.
Yeah, so sessions you probably want to find some sort of data store for. So pick a data store, something like Redis or Memcached maybe, and store your sessions in there. But other than that, no, absolutely no reason why you couldn't do that.
Cool, perfect. Next time, before we say goodbye, next time, same place next week, we are actually going to be talking about Lambda performance tuning. So not just Java, but all kind of languages with Luca and Matt. So that's going to be fun. And don't forget as well, on serverlessland.com, everything to do with serverless on AWS, guides, workshops, code examples, anything you can think of, lots of good stuff. Well, Mark and Max, I really appreciate you spending the time today to join us. And yeah, lots of cool stuff. Jerome thought so as well, so it's not just me. But yeah, we appreciate it. I appreciate all the hard work putting this together. And thank you very much.
Thank you so much, and have a good day.